Hi, my name is Israel Herrera. I am a student of the doctoral program of Production and Industrial Engineering in the University Politécnica of Valencia. I'm going to present this work called A Forecasting Model to Predict the Demand of Rose in Ecuadorian Small Business under uncertain scenarios. In this case, we have the sponsor of the RUCAPS project. As a motivation and context, we have the, the floriculture sectors, the floricultural sectors from Ecuador represents one of the main income source for the Ecuadorian country. In this case, we have a appropriate climate to grow the Ecuadorian rose is a start product of high quality of rose which is sold in other countries like United States, Russia, and the European Union. For that reason, this market represents the dynamization of the economy of the northern area of Ecuador. The problem is that some some companies dedicated to grow and to process quality rows daily face problems with some scenarios from uncertainty, such as the difficulty in access to bank credit, the constant growth of the inflation and the appearance of new local taxes and tariffs, and the increase of the level of unemployment in this country. One of the goals for this research is that there is a need to design a specific demand forecasting model for the rose sector that consider previously mentioned variables. In addition, this model should be constantly updated to reduce uncertainty in flower production scenarios and make better demand decisions that optimize the agricultural supply chain and the appropriate use of the weather, and the soil for crops. As a case of a study, we have a company located in the north of Ecuador. Is located in the Pedro Moncayo village. It consists in a small business dedicated to the production of high quality rose uh, and some artificially dyed are marketed in in this case. One of its main objectives is to optimize the management of the post-harvest process through a forecasting of the future demand and balancing its installed and supply with his demand. As a methodology, we have two phases to solve the problem. The phase one is a macro forecast of tons of Ecuadorian rose to be exported with a data of historical demand from 1990 to 1919. In this case, we used a multi-layer perceptron to forecast the demand uh, in this case. The phase two is a micro forecast of rose varieties offered by the company studied. We have a database from 2017 to 2019 year. In this phase, we used 7 forecast models and compared between them, and we used to this goal the root of medium square error. In this case, the 7 forecast models are whole winters, autoarima, exponential smoothing, linear regression, neural network, multi-layer perceptron, Bayesian network with Markov chain Monte Carlo sampling algorithm to simulate the posterior distribution. This model is based in the work of Scott. For the micro forecast, we design a Bayesian network for the micro forecast demand. In this case, we have some exogenous variables. For example, the climate variability, the variability employment deviation in Ecuador, the index of economic activity, the deviation of the Ecuadorian rose sector's gross domestic production, the inflation rate variable, and the historical monthly demand. As you can see, we have in this case plotted these exogenous variables, uh, but we have to normalize this data. We have to use this equation number one to normalize the exogenous data called predictors. As you can see, we have some patterns, some different patterns in that variables. Um, as a result of the macro forecast or phase one, we have that the best result specifically in a RMSA indicator of 1.3 was obtained with a manual parameter selection using the pyramidal rule to determine the number of nodes in its 3 hidden layers. We have 3 hidden layers with 22, 18, and 15 perceptron or nodes, and we have to apply 40 repetitions and an automatic selection of frequency delays. In this picture, we have the architecture of the MLP multi-layer perceptron, and in the right side we have the result of the forecast model. In this case, we have the forecast for the year 2020. As a result of the phase two, it's important to tell that the phase two used the result of the forecast from the phase one. We used this data to know the market, the national market of roses in Ecuador, and with that data, we can to learn and to plan what part of the market we can use to offer our roses for our factory in this case. Um, for the phase two, we have to micro forecast the four varieties of roses sold by the case study company. In this, we have seven forecast models like whole winters, autoarima, exponential smoothing, neural network, linear regression, multi-layer perceptron, and a Bayesian network. As a result, we have this plot, and we can see that the best results are provided by the multi-layer perceptron forecasting model. But in this picture, we can see the results of the Bayesian network designed. But the difference is that we have to use the cumulative absolute errors, and in the posterior picture we used RMSA indicator is and these are two different indicators of error in the forecast. As a result, we can see that with the Bayesian network, we have the errors calculated through the prediction standard step standard deviation. And in this case, we can see that it's not that the previously indicator error, but is a good result provided by the Bayesian network based in the work of Scott. These results were good for the four varieties of roses offered by the case studied company. We have to use the R statistical language to develop a code to forecast the demand with a Bayesian network. As a conclusion for this article, we have that it is so important to establish a standardization process that detects in equal conditions the variation for each predictor in the analyzed time interval, so that finally these patterns can be projected to the future. The, the mentioned Bayesian network with the five predictors and the historical series of monthly data of the last 4 years show acceptable values in the standard deviation of the errors of a step forward in the prediction. However, it was not possible to compare this indicator against other forecasting models reviewed in the literature. For that reason, it is recommended as in the future works to create new error indicators in the forecast model to allow a comparison between deterministic forecasting methods and stochastic models such as Bayesian network. And finally, we have to include in the Bayesian network model a new variable that reflects the global risk of pandemics that affect negatively to the production of rose, as in the case we are facing with the COVID-19 pandemic. Finally, we have to acknowledge to the RUCAP's European project and to the SDAS group that sponsored this research. And thank you for your attention.